Analysis of structures. The term structure can refer to any object that has the capacity to support and exert loads. In this video, we consider structures composed of interconnected parts or members. To design such structure, or to determine whether it is adequate, you must determine forces acting on the structure as a whole as well as on its individual members. Two types of structures are pin-connected trusses and pin-connected frames. Trusses: the internal force in a bar directed along the axis of the bar. Frames: the members are subjected to bending action. Simple trusses. A truss is a structure composed of slender members joined together at their endpoints. The members commonly used in construction consist of wooden struts or metal bars. In particular, planar trusses lie in a single plane and are often used to support roofs and bridges. Truss structures composed of members fastened together in such a way as to resist change in shape as a rigid structure. Each member is straight, of negligible weight, and joined at its ends only. The center lines of the members lie in one plane called the plane of the truss. The center lines of members meeting at a joint are concurrent. Members converging at a point are joined by a frictionless pin set perpendicular to the plane of the truss. The loads are applied to the truss at the joints only. The loads lie in the plane of the truss, and each load does not produce bending or torsion in any of its members. Assumption of simple trusses. Members of these trusses are joined together by means of pins, riveting or welding them to a common plate. Trusses are so constructed that all applied loads act at the end of the members. The weight of the truss members is negligible in comparison with the applied loads. In case the weight is not negligible, calculations are made on the assumptions that the weight of each member is divided equally into two forces, which act vertically downward. Parts of a simple truss. Cross beams are central vertical posts working in tension to support a beam below from a truss apex above. Side truss serves as a frame supporting each member of the truss. Stringers are horizontal beams to connect uprights in a frame or to support a floor. The floor of the truss serves as a brace to make sure that stringers are intact with each other. If a truss is in equilibrium, then each of its joints must also be in equilibrium. The method of joints consists of satisfying the equilibrium conditions for the forces exerted on the pin at each joint of the truss. It consists of taking the truss apart, drawing separate free body diagram of each member and each pin, and applying the equations of equilibrium to each part of the truss in turn. Say you are to find the reaction at the middle joint of the bridge, when there are two cars exerting force downward. First, you get the reaction and drawing an FBD at the joint with less unknowns, and the next one until you reach the required joint and getting its reaction. The method of section is used to determine the loadings acting within a body, It is based on the principle that if a body is in equilibrium, then any part of the body is also in equilibrium. To apply this method, one passes an imaginary section through the body, thus cutting it into two parts. When a free body diagram, one then applies the equation of equilibrium to the part in order to determine the loading at the section.